That's exactly what scientists felt when the James Webb Space Telescope, the most powerful eye ever launched into space, detected something completely unexpected. This wasn't just another distant galaxy or a beautiful nebula to add to NASA's image gallery. This was a set of signals, patterns, and anomalies that defied every rule we thought we understood about the cosmos. At first glance, it all seemed random. But the deeper they looked, the more it began to feel deliberate, structured, and, some would even say, intelligent. For decades, we believed that the universe was indifferent to our existence, a cold, endless void governed by physics and chance. If we've been wrong all along, hidden in the silence of deep space, there are messages waiting to be found, messages that we were never supposed to see. Today, we dive into the latest data from the James Webb Space Telescope data, so shocking, so unprecedented, that some astronomers are beginning to ask The journey began with an unexpected anomaly close to home. James Webb was pointed toward Neptune, one of the ice giants at the edge of our solar system, a planet so distant and cold that it often seems frozen in both time and space. Compared to the data collected by the Voyager 2 flyby in 1989 and more recent Earth-based telescopes, Neptune's upper atmosphere had dropped in temperature significantly, not over millennia or centuries, but within just a few decades. The readings were clear. Parts of the atmosphere had cooled by nearly 10 degrees Celsius without any clear cause. Solar cycles didn't explain it. Internal heat fluctuations didn't either. And here's the unsettling part. Webb also detected unusual shifts in Neptune's magnetosphere, subtle but real. Like a silent pulse from a heart we never knew was beating. While the anomaly around Neptune stirred unease, what James Webb found in the TRAPPIST, one system was enough to make scientists reconsider their entire approach to exoplanetary science. Located just 39 light-years away, TRAPPIST-1 is already famous for hosting 7 rocky planets, 3 of which orbit within the system's habitable zone. Using infrared spectroscopy, Webb identified the unmistakable spectral fingerprints of water vapor in the atmospheres of at least 2 of those planets, TRAPPIST-1D and TRAPPIST-1E. And this wasn't just trace amounts. The data suggested dense, humid atmospheres, possibly with cloud systems resembling Earth's, combined with temperature profiles and orbital resonance patterns. The most likely scenario is this global ocean's deep, stable, and ancient. Even more astonishing was the detection of ozone-like compounds, molecular markers that, on Earth, are linked to biological processes. It's not proof of life, but it's as close as we've ever come to finding the right conditions for it. Not once, but twice on 2 planets in the same star system. Imagine it, a miniature solar system with not one, but multiple Earth-like worlds circling quietly in the darkness. And now, Webb has shown us they are more than theoretical targets. They are real, vibrant, and potentially alive. While the revelations near our cosmic neighborhood were already staggering, James Webb had its eyes on a far more ancient realm. In one of its deepest surveys, it captured light from a galaxy known as JADES, GSE 13-0, one of the oldest ever observed, formed just 330 million years after the Big Bang. But it wasn't just the galaxy's existence that puzzled researchers, it was the Lyman alpha radiation it emitted, a frequency usually absorbed by clouds of neutral hydrogen in the early universe. And yet, this signal was far too strong, far too clear, as if the hydrogen had already been ionized, allowing the light to travel unimpeded. This completely overturns what we thought we knew about the epoch of reionization, the era when the universe transitioned from darkness to light. If this galaxy emitted that radiation so early, it suggests something might have accelerated that process, something massive or perhaps intelligent. Was it just natural variation, or the footprint of something more deliberate, like the early fingerprints of galactic engineering, or some unknown energy process igniting the cosmos before it was ready? The implications are staggering. It's no longer just about what happened. It's about why and who, if anyone, was there to make it happen. As the telescope shifted its gaze to white dwarf system stars that have already died, scientists expected only debris, silence, and In the system of WD 1856 plus 534, Webb detected a massive gas planet orbiting just a few million kilometers from the dead star. This shouldn't be possible. The transformation of a sun into a white dwarf usually destroys everything nearby. Yet here was this planet not only intact, but apparently in equilibrium. What stunned researchers most was what they saw in the planet's upper atmosphere. Webb's instruments picked up traces of vaporized water, sulfur compounds, and other chemical markers suggesting atmospheric regeneration. And suddenly, white dwarfs, once symbols of cosmic endings, might just be the best places to look for intelligent life enduring in the ashes of ancient worlds. What the James Webb Telescope is revealing isn't just beauty, science, or wonder. It's something deeper. A series of signs scattered across space and time, each one challenging the boundaries of what we know and whispering the same silence. From the cold shadows of Neptune's moons to the structured pulses of distant galaxies, from the possible oceans on TRAPPIST worlds to the dark silhouettes moving behind cosmic curtains, Webb hasn't just opened a new eye to the cosmos. It's peeled back a veil. We stand on the edge of a discovery that could redefine our species, a realization that the universe is not only vast, but perhaps aware, watching, responding, or even warning. Lastly, James Webb turned its optics to able. This chaotic conglomerate of galaxies has always fascinated astronomers due to its gravitational lensing, which allows us to see galaxies from the earliest universe. In one corner of the observation, shadows passed across a background galaxy not once, but multiple times during long exposures. These were not instrumental errors, they were actual occultations, meaning something moved in front of the distant light source. But here's the mystery. Nothing visible cast those shadows. Whatever passed through that lens did not emit light, did not reflect it. It was only known through what it blocked. Based on the speed, size, and recurrence, Webb's team believes these objects might be massive yet dark, possibly stealth satellites, or, more exotically, non-reflective megastructures. When scientists began comparing Webb's datasets from these different discoveries, Neptune's pulse, TRAPPIST oceans, the ancient galaxy's impossible light, and the shadows in Pandora's cluster, they noticed something they weren't prepared for. Tiny, seemingly insignificant alignments buried deep in the data. Frequencies repeating across different observations. Infrared pulses matching ultraviolet fluctuations. Magnetic oscillations on Neptune that resonated faintly with timing irregularities in distant galaxies. Maybe, but the statistical probability said otherwise. These weren't random. They were synchronized, as if multiple points in the universe were somehow connected, communicating or responding to the same unseen source. In late 2025, Webb's instruments detected an echo, an infrared reflection emanating from a patch of empty space between two known quasars. At first, scientists thought it was just a background calibration error, but when they analyzed it, the echo repeated. Not once, not twice, but continuously, like a faint transmission looping through cosmic. It wasn't a radio signal, nor a standard electromagnetic signature. It was something else encoded within infrared radiation itself. One researcher described it as a whisper embedded in light. Another said it looked eerily similar to digital compression artifacts, the kind you find in human-made data. If that's true, then the implications are staggering. Somewhere in the deep void, something is transmitting not through sound or radio, but through the structure of light itself. The signal wasn't strong enough to decode directly, but when researchers converted its pattern into audio frequencies, a strange, rhythmic pulse emerged. To the untrained ear, it sounded like nothing more than static. To signal processing experts, it resembled something profoundly artificial, XA repeating code, structured like a countdown or a calibration pattern.